Welcome back, guys. So I hope you have seen my video lecture 1 and video lecture 2 on general organic chemistry, wherein I was discussing about inductive effects, positive inductive effect, negative inductive effect, and the applications of inductive effect. Okay, I have told you in detail about the applications of inductive effect related to the strength of acids. So please recollect. Okay, please recollect or memorize what we have studied in video lecture 1 and video lecture 2. So when do you say an acid is going to be a strong acid? Okay, yes, I will show it here. Okay, yes, if this is an acid, okay, it gives H plus ions and A minus ion, isn't it? Okay, when will you say that this is a strong acid and a weak acid? If the anion of this acid is more stable, then this will be a strong acid. If the anion of if this anion is less stable, then this is going to be a weak acid. Any factor which increases the stability of this anion increases the stability. Any factor which decreases the stability of this anion decreases the acidic nature, isn't it? That is what we have learned. And further, I have also told you that if there is a negative minus I group, a minus I group increases the acidic nature. More the number of minus I groups, more will be the acidic nature. Okay, and the presence of plus I group in the molecule decreases the acidic nature. More the number of plus I groups, lesser will be the acidic nature, isn't it? And inductive effect decreases with distance. As the distance increases, inductive effect will decrease. Okay, so with this concept again we shall solve few more problems so that we will be expertised. Okay, in inductive effect we can solve any problem, okay, which is based on inductive effect. So we will continue with the problems now. Okay, can you please answer this question? Okay, yes, this question is option A, B and C. Okay, yes, you have to tell me. Okay, which is that effect which is acting here? Okay, look at here, CH, this is an alkyl group, isn't it? Alkyl group. What type of alkyl group is it? A secondary alkyl group. Okay, here again an alkyl group. Which alkyl group is it? Okay, primary alkyl group. We know alkyl groups will exhibit positive inductive effect. So that means here we can observe positive inductive effect, positive inductive effect. Okay, yes. Whereas here we have chlorine. Chlorine will exhibit what type of effect? It will exhibit negative inductive effect, isn't it? Obviously, any group, minus I groups will increase the acidic nature. Therefore, in this question, obviously C is going to be a strong acid. But among them, among these two, which is going to be a strong acid? Among these two, that which exhibits less positive inductive effect. So we have secondary and we have primary. Among them, which will exhibit less positive inductive effect? It's primary. Okay, here the positive inductive effect is less, therefore the acidic nature will be more. Hence, C is more acidic than B, B is more acidic than A. I hope it is clear. Yes, next question. We have formic acid and acetic acid. Here there is no effect, neither positive or negative. No effect. Okay, but here we have what? CH3 group. CH3 group will exhibit what type of effect? Positive inductive effect. Obviously, if there is a positive I group plus I group, acidic nature will be less. So what is your answer among these two? Okay, yes, A is more acidic than B. Okay, B is less acidic because of plus I group. Simple. Yes. Next, we have acetic acid, chloroacetic acid and hydroxyacetic acid. Okay, can you please answer? Here we have CH3 group plus I effect. Here we have Cl group minus I effect. Here we have OH group minus I effect. So we have two groups which is exhibiting negative inductive effect. Among them, which will exhibit more negative inductive effect is going to be a strong acid, isn't it? If negative inductive effect is more, acidic nature will be more. If positive inductive effect is more, acidic nature will be less. So among these two negative I groups, which one will exhibit more negative I effect? Okay, which one will exhibit more negative inductive effect? So you have to look into the order. In the order, which comes first? It's chlorine. Okay, isn't it? You have to look into my previous video and refer to the order of negative inductive effect and order of positive inductive effect. Okay, so in the order, so we have seen that chloro group, chlorine will exhibit more negative inductive effect than hydroxyl group. That means this is more acidic than this, and finally this. So what is the correct answer? It is B greater than C greater than A. Okay, yes. Next one. Guys, very simple. We have, okay, formic acid, acetic acid and chloroacetic acid. Here, as I said in that option, there is no effect here. There is no effect here. Here we have alkyl group. Alkyl group will exhibit positive inductive effect and chlorine will exhibit negative inductive effect. Isn't it? Negative inductive effect. Obviously, the group which shows negative inductive effect will increase the acidity. So what will be the correct answer here? Yes, it is C greater than A greater than B. Okay, yes or no? Plus I group will decrease the acidity, minus I group will increase the acidity. Hence C is greater than A greater than B. Yes, guys, in all these options, in all these questions, we took one class of organic compound. Here we discuss the acidity of carboxylic acids. In the next question also we discuss the acidity of carboxylic acids, acidity of carboxylic acid, and okay, yes, here also the acidity of carboxylic acid. But in this question we have alcohols as well as carboxylic acids. We have alcohol, we have carboxylic acid, we have phenol as well as water. If there is only carboxylic acid in the question, yes, we can answer based on inductive effect. We know if there is only alcohols in the given question, we can answer them on the basis of inductive effect. But if the question has alcohols, phenols, carboxylic acids, etc., 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 so many different classes of organic compounds, then to explain the acidic nature only on the basis of inductive effect is very difficult. Okay, to explain the acidity of, okay, yes, given classes of organic compounds only on the basis of inductive effect, it is very difficult. Okay, or else we cannot explain the acidity only on inductive effect or only on some other phenomena. Okay, the best method to explain the acidic nature or the basic nature is based on Ka values and Kb values, which we will study later in our upcoming videos. Okay, so now, if you want to answer this question, as I told you, if you have, okay, different classes of organic compounds, as I said, this is alcohol, carboxylic acid is there, phenol is there, water is there. Now, in this case, it is quite difficult to answer, okay, to decide the nature of nature of acidic nature only on the basis of inductive effect. So therefore, in order to answer this question, we have to remember the order of acidic nature. Okay, we have to remember the order of acidic nature. What is that order? So please, if you remember the order, what I'm going to write now, okay, okay, you can answer any question, okay, yes. Please remember the order of acidic nature. See the order of acidic nature here. Order of acidity. Order of acidity. See this. Please remember this order. Okay, if you can remember this order, you can answer any question based on the strength of acids or the strength of bases. Okay, but now I am giving you the order of acidity. The order says, okay, benzene sulfonic acid is a strong acid than formic acid. Formic acid is a strong acid than, okay, benzoic acid. Benzoic acid is a strong acid than any carboxylic acids, alkyl carboxylic acids. Carboxylic acids are strong acid than carbonic acid. They are strong acids than phenol. Okay, phenols are strong acids than water. Water is strong acid than alcohol. Okay, alcohols are strong acid than alkynes. Okay, alkynes are strong acids than benzene. Benzene is a strong acid than alkene. Okay, alkenes are strong acids than alkanes. Please do remember this order. Okay, I hope you understood. When you're going to use this order, when the question, okay, has different class of organic compounds. If the question has same class of organic compounds, that means in all the options, if there is only alcohols, in all the options, if there is only carboxylic acids, then the strength, acidic strength, can be judged based on inductive effect, isn't it? But if the option has different classes of organic compounds, then in that case, I want you to remember this order. What is that order? Benzene sulfonic acid is a strong acid than, okay, formic acid. Formic acid is a strong acid than benzoic acid. Benzoic acid is a strong acid than any alkyl carboxylic acids, then carbonic acid, then phenol, then water, then alcohols, then alkynes, benzene, alkenes and alkanes. Now based on this order, can you answer this question? Can you arrange these molecules in the increasing order or decreasing order of acidity, please? Okay, can you please arrange them? Yes, look at this. We have alcohol, we have benzoic acid, we have phenol and water. So which one is a strong acid according to that rule, according to that order? Obviously benzoic acid is a strong acid then what? Benzoic acid is a strong acid than phenol, isn't it? Yes, B is a strong acid than phenol. Phenol is a strong acid than water. Phenol is a strong acid than water. Okay, yes, water is strong acid than alcohols. Okay, yes, water is strong acid than alcohols. What is the correct option here? It is B, greater than C, greater than D, greater than A. I hope you have understood. Yes. Okay. Now we will answer the other questions based on this acidic nature. Okay, the order of acidic nature. Shall we? Okay, yes. Direct. Okay, we have water, we have alcohol and we have alkynes. Yes, what is the order? Water is a strong acid than alcohol. Alcohol is a strong acid than alkynes, isn't it? Correct? Water is a strong acid than alcohol. Alcohol is a strong acid than alkynes. So what is the correct answer? Here A is a strong acid than B. B is a strong acid than C. Okay. Yes. Next question. Okay. We have formic acid, acetic acid, benzoic acid and phenol. Come on. Okay. What is the order? Yes. Formic acid is a strong acid than benzoic acid, then carboxylic acids, then carbonic acid, then phenol. So what is this? Yes. Okay. Yeah. Okay. Formic acid is a strong acid than benzoic acid. Benzoic acid is a strong acid than carboxylic acids. Okay. So carboxylic acid is a strong acid than phenol. So here the correct order is A greater than C, greater than B, greater than A, isn't it? Yes. Next question. Yeah, there is something to be noted here. We have formic acid, we have acetic acid, we have benzoic acid, then iodoacetic acid. Okay, so you will say obviously, okay, yes, what is it? You will say that, okay, formic acid is a strong acid than benzoic acid. Benzoic acid is strong acid than carboxylic acids, isn't it? So you will say that the order is A greater than C, okay, because formic acid is strong acid than benzoic acid and benzoic acid is strong acid than what? Carboxylic acids. So we have two carboxylic acids here. So in one carboxylic acid we have alkyl group and in the other carboxylic acid we have iodo group. Okay, alkyl group will exhibit positive inductive effect. Okay, iodo group will exhibit negative inductive effect. So we know if there is negative inductive effect, acidic nature will increase. So therefore you say that D is more acidic than B. D is more acidic than B, isn't it? You will say this is the correct order. No, this is not the correct order. See, in the given options, if you find, okay, any group which exhibits negative inductive effect, then that, okay, that option is going to be a strong acid. Please note that point. This is not the correct answer. This is not the correct answer. In any option, if you find, okay, a group exhibiting negative inductive effect, then that option will be taken as a strong acid. Understood? So in all these options, we have a group which is exhibiting negative inductive effect. Therefore, this is going to be a strong acid. This is going to be a strong acid. Hence, what will be the correct order? The correct order is D greater than A, greater than C, greater than B. Understood? Yes. I hope it is clear. Yeah, D greater than A, greater than C, greater than B. Any doubts? Yeah. Okay. Now, in the next option, guys, here also you have to be very careful. We have benzoic acid, okay, we have nitrophenol, and what is this? Methyl, para-methyl benzoic acid. Para-methyl benzoic acid, we have para-nitrophenol. We know nitro group is negative inductive effect, okay, methyl group is positive inductive effect, correct? So in the given order, benzoic acid is a strong acid than phenol, isn't it? Okay, so we have two benzoic acids. Okay, yes. So, okay, obviously option A will be a strong acid because it's a benzoic acid, isn't it? But among them, which is going to be a strong acid? Look here, in the given options, if you have substituted benzoic acid and substituted phenol, okay, whatever may be the groups, okay, always benzoic acid will be a strong acid than phenol. Note this point. Whatever may be the groups, whether it might be plus I group or minus I group, always, okay, benzoic acid is going to be a strong acid than phenol. Hence, what will be the correct order here? A is greater than C, greater than B. Please note this point. Note this point. Okay, I will write that irrespective of groups, okay, yes, irrespective of groups, okay, yeah, benzoic acid, okay, is always a strong acid than what? Phenols, okay. Yes, you can have minus I group or plus I group in benzoic acid. Okay, it is always a strong acid than phenol. That is why para-methyl benzoic acid is a strong acid than para-nitrophenol, even though nitrophenol has minus I group. Okay, even though para-nitrophenol has minus I group, okay, yes, this benzoic acid will always be a strong acid than phenol. Note this point. Irrespective of groups, benzoic acid is always a strong acid than phenol. Any doubts? Yes. Now, I have a next question. What is that? Okay, look at here. I'll go with this question. Okay, in option A, I have para-nitrophenol, okay, meta-nitrophenol, and in option C we'll have, okay, we have this. See, we know that this position is ortho, para, meta, para. That is why I said that is para. Okay, I'm sorry, extremely sorry. Okay, yes. This is para position, ortho position, meta position, para position. Okay, isn't it? This is para position, ortho position, meta position. Here we have para position, ortho position, meta position, and para position. And we also know that NO2 group is minus I group, isn't it? Minus I group. Okay. If the negative inductive effect increases, acidic nature will increase. So here, okay, we have nitro group, minus I group, minus I group, minus I group. Okay. Here also minus I group, and minus I group, isn't it? Okay, if negative inductive effect increases, acidic nature increases. So what is the correct order? You should remember one point here. Note, okay, note inductive effect, yes, is more at ortho and para position, okay, yes, least at meta position, isn't it? Okay, yeah, inductive effect is more at ortho and para position, but it will be less at which position? Meta position. So here we have, okay, NO2 group at para position. Therefore, here negative inductive effect will be more. Since the negative inductive effect is more, okay, this is going to be a strong acid. Okay, here nitro group is at meta position, but negative inductive effect is least at meta position, therefore this is going to be a least acidic. So, okay, and in between them we have nitro group at both para position as well as meta position, so this comes next. Okay, so this is going to be the correct answer. A greater than C greater than B. Okay, inductive effect is more at ortho and para position, but it will be least at meta position. Any doubts? Yes. Yes, guys. Next question. So again, okay, in decreasing order of acidity, we have fluoroacetic acid, bromoacetic acid, chloroacetic acid, and diiodoacetic acid. Diiodoacetic acid. So we know the order of negative inductive effect: fluorine more than chlorine, more than bromine, more than iodine. Okay, so that means this exhibits negative inductive effect, this exhibits negative inductive effect, this exhibits negative inductive effect, isn't it? Here there are two iodine, therefore there are two negative inductive effects here. Two iodine, therefore two negative inductive effects. I have told you that if the negative inductive groups minus I groups increases, okay, yes, if the minus I groups increases, acidic nature will increase, isn't it? So which is going to be the strong acid here? This is going to be the strong acid because there are two minus I groups, hence D is going to be a strong acid. Which is going to be the next one? Okay, that which exhibits more negative inductive effect. Which one exhibits more negative inductive effect among fluorine, chlorine, bromine? Okay, it is fluorine, isn't it? So therefore it is going to be next option A, then C, then B. Is this correct? So why this became the strongest acid? Because there are two negative inductive groups. Hence this is a strong acid than than A, C and B. Okay, so you just have to follow the order of negative I group. Yes, next question. Look here, we have trichloroacetic acid, difluoroacetic acid and triiodoacetic acid. So here there are three chlorine atoms. Three chlorine atoms means 3 minus I groups. Here we have two fluorine atoms, means 2 minus I groups. Here we have 3 iodine atoms, that means 3 minus I groups. Okay, obviously as the negative inductive groups if minus I groups increases, acidic nature increases, isn't it? So we have two things, 3 minus I groups, 3 minus I groups. Among chlorine and iodine, which exhibits more inductive effect? It's chlorine. Hence it's option A, okay, more than C, more than B, isn't it? Okay, yes, in option A and C we have 3 minus I groups, so more will be the acidic nature. Okay, among chlorine and bromine, it is chlorine which exhibits more negative inductive effect, hence option A is more acidic than option C, more acidic than option B. Yes. Now, very important. It's question. Okay, we have what is this? Ethanol, and we have ethylamine. Ethanol and ethylamine, or ethyl alcohol and ethylamine. So among them, which is a strong acid? Which is a strong acid? Can you please tell me? This is alkyl group, that means positive inductive effect. This is also alkyl group, this is also positive inductive effect, same groups. Now among them, which is a strong acid? Can you please tell me? See, upon losing H plus ion, this will give CH3, CH2, O minus, isn't it? Okay, here upon losing, okay, H plus ion, this is going to give CH3, CH2, okay, NH2 minus, isn't it? Okay, CH3, CH2O minus, CH3, CH2, NH2 minus upon losing H plus ion when dissolved in an aqueous solution. Okay, is that correct? Now, among them, which is a strong acid? I told you, okay, an acid is going to be strong only when its anion is more stable. So now you have to judge whether this anion is more stable or this anion is more stable. So for that, we have one more rule. See this. If you can remember this rule, you can answer this question. What is that rule? Okay, note this point. Okay, if more electronegative atom, if more electronegative atom carries negative charge, okay, then this is going to be more stable. So here oxygen is also electronegative, it is carrying negative charge. Nitrogen is also electronegative, it is carrying negative charge. But among them, which is more electronegative? Obviously oxygen is more electronegative than nitrogen, hence this anion is more stable than this anion, therefore this is going to be a strong acid than this acid, isn't it? So what is the correct answer here? A is greater than B. I hope this is clear. Okay, my rule says if more electronegative atom carries negative charge, then that anion will be more stable. So here oxygen is carrying negative charge and nitrogen is carrying negative charge. Oxygen is electronegative, nitrogen is also electronegative, but oxygen is more electronegative than nitrogen, hence this anion is more stable than this anion, therefore this is a strong acid than this acid. Okay, so the correct answer is A greater than B. Okay guys, so all these questions is based upon the rule what I told you earlier. What is that? Okay, if more electronegative atom carries negative charge, then that anion will be more stable, therefore it will be more acidic. Okay, so you can answer these questions by looking at this order itself, but you should know the exact reason why this order comes, isn't it? So if I say this question, can you please answer this question, what is the order of acidity? By looking at the rule you will say, okay, alkynes are more acidic than alkenes, alkenes are more acidic than alkanes. So you will say A is more acidic than B is more acidic than C. But why? Why alkynes are more acidic than alkenes and why alkenes are more acidic than alkanes? So you can say, okay, look at here, upon losing electrons, see this will give CH, okay, triple bond C minus, isn't it? Upon losing H plus ion. This upon losing H plus ion, it will give CH2 double bond CH minus. This upon losing H plus ion will give CH3 single bond CH2 minus. Well, this carbon is sp hybridized, this carbon is sp2 hybridized, and this carbon is sp3 hybridized. Okay, if there is triple bond next to carbon, then that carbon will be sp hybridized. Okay, if there is double bond next to carbon, then that carbon will be sp2 hybridized. If there is only single bond next to carbon, then it is going to be sp3 hybridized. Okay, so in this question, the anion, the carbon is sp hybridized, here the carbon is sp2 hybridized and carbon is sp3 hybridized. We know that sp hybridized carbon is more electronegative than sp2 hybridized carbon. sp2 hybridized carbon is more electronegative than sp3 hybridized carbon. Look at the order of electronegativity here. sp hybridized carbon is more electronegative than sp2 hybridized carbon. sp2 hybridized carbon is more electronegative than sp3 hybridized carbon, isn't it? So that means this carbon is more electronegative than this carbon and this carbon. So a more electronegative carbon carrying negative charge will be more stable. If it is more stable, this is going to be a strong acid. So that is why alkynes are strong acid than alkenes, alkenes are strong acids than alkanes. I hope there is no doubts. Now, okay, based on the same concept, can we answer the next question? Okay, obviously alkynes are more acidic than benzene. Benzene is more acidic than, okay, alkenes. Alkenes are more acidic than alkanes. This is the correct order. Okay, now look at here, among alkenes and benzene. Among alkenes and benzene, see this, okay, alkenes, CH2 double bond CH2, okay, and benzene. Well, see this upon losing, okay, H plus ion, it will give CH2 double bond CH minus. Is that correct? Yes. This upon losing H plus ion, this is also going to give minus. Okay. Okay. This carbon is sp2 hybridized. Okay. Carbon next to double bond is sp2 hybridized. Carbon next to double bond is sp2 hybridized. So this is also sp2 hybridized. This is sp2 hybridized. This is also sp2 hybridized. But benzenes are more acidic than alkenes. Why? Isn't it? Benzene is more acidic than alkenes. What is the reason? Okay, no doubt this is sp2 hybridized, this is also sp2 hybridized carbon. Both are equally electronegative, but on the negative charge on this carbon is resonance stabilized, which we will see in the next class. The negative charge on this sp2 hybridized carbon is resonance stabilized. That means this is more stable. Hence, benzene is more acidic than alkenes. Okay, I hope there is no doubts. Fine. Okay, next question. Next question is like this. We have, okay, CH3, okay, NH3, H2O and HF. Is it CH3 or CH4? Okay, yes, let us take that we have CH4. We have CH4, NH3, water and HF. Among them, which is going to be a strong acid? Please think. See, this upon losing H plus ion, it will form CH3 minus, isn't it? Okay, yes, this upon losing electron will form NH2 minus. This upon losing H plus ion will form OH minus. This upon losing H plus ion will form F minus. Is that correct? Okay, methane upon losing H plus ion form CH3 minus. NH3 upon losing H plus ion will form NH minus. Okay, H2O upon losing H plus ion will form OH minus, and HF upon losing H plus ion will form F minus. Now just think, which of these anions is more stable? What is the rule? The rule says, okay, a more electronegative atom carrying, okay, negative charge is more stable, isn't it? So which among them is more electronegative? Obviously fluorine is more electronegative, okay, then oxygen, then nitrogen, then, okay, carbon, isn't it? So what is the order of stability here? This is more stable than this, this is more stable than this, okay. Then what is the order of acidity? Okay, if the anion is more stable, then this acid is going to be a strong acid. If the anion is more stable, then this acid is going to be a strong acid. Hence, what is the order of acidity? Order of acidity is D greater than C, greater than B, greater than A. Okay, is this correct? Yes. Okay, yeah, yes. I have one more question. Okay, I have taken one more question from your MTG fingertips. It's question number 47. Okay, yes, you can just look into your MTG fingertips. Okay, the question says, which of the following is the correct order of acidity of carboxylic acid? Which of the following is the correct order of acidity of carboxylic acids? So all of them are carboxylic acids. That means you can judge the acidity through inductive effect. Again, negative inductive effect will increase and positive inductive effect will decrease the acidity. More number of minus I groups, more is acidity. Less number of more number of plus I groups, less will be the acidity, isn't it? So here we have chlorine, chlorine, chlorine. So minus I effect. Here there are 3 chlorine, that means 3 I effects. Okay, here so 3 minus I effects, here 2 minus I effects. So here only 1 minus I effect, only 1 minus I effect. So more the number of minus I groups, more will be the acidity. So therefore this option is correct, isn't it? Next, so then we have CH3, CH2, 1 plus I group. Here we have CH3, CH3, that means 2 I plus I groups, isn't it? Alkyl groups are plus I groups. See here we have CH3, 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 that means 3 plus I groups. So more the number of plus I groups, less will be the acidity, isn't it? Is this the correct order then? Yes, more the number of plus I groups, less will be the acidity. So this is also the correct answer. Then, okay, look here, we have fluorine, fluorine, chlorine. Fluorine, fluorine, chlorine. Here we have 2 minus I groups. Here we have only 1 minus I group and minus I group, only 1 minus I group. Okay, among fluorine and chlorine, which will exhibit more minus I group? minus I effect, it is fluorine. Hence, fluoroacetic acid is a strong acid than chloroacetic acid. That means this option is also correct. So what is the correct answer then? It is option D. 1 is correct, 2 is also correct, and 3 is also correct. Yes. Yes, guys. So I have taken a question. Okay, see, this question has appeared, a very simple question has appeared in NEET 2017. Okay, see how simple it is. If you just remember this order of acidity, you can answer this question. The question says, which one is the correct order of acidity? See, we have alkynes, alkenes, and alkanes. Isn't it? This itself is the correct answer, because alkynes are strong acids than alkenes. Alkenes are strong acids than, okay, alkanes. So that's it. Okay, isn't it? We have alkynes, okay, alkenes and alkanes. So this itself is the correct order of acidity. You can check with the correct other options. Here we have in the second option, why this and this is not the correct option? Because in the second option we have alkynes followed by alkenes followed by alkynes. No, obviously alkynes are strong acids than alkenes. So this cannot be the correct answer. In the third option we have alkanes as the strong acid. No, alkanes are least acidic. In option D, okay, observe the last thing, okay, the last thing is given as alkynes. That means they are telling that alkynes are least acidic. No, alkynes are more acidic than alkenes as well as alkanes. So this cannot be the correct option. What is our correct option? It is option A. Yes. So with this, guys, okay, I am going to complete the inductive effect. In my next video, I'll come up with the next electron displacement effect. What is it? It is mesomeric effect or resonance effect. Okay, so please keep revising all my videos and learn the inductive effect thoroughly. Okay, thank you.